this is Mr. Peterson. This screencast is about velocity and speed. So those are two important concepts, especially when we talk about motion of things. When we can talk about measuring things, eventually it's going to lead into Newton's second law, force equals mass times acceleration. So here I cut myself, doing a little skateboarding, doing a frontside ollie there across the way there. Maybe back in the day, I don't know if I could do that anymore. So what is the difference between those two, between speed and velocity? So I think you know the formula for speed. It's the ratio of distance divided by time. So miles per hour, kilometers per hour, meters per second, those kinds of things. So how fast something's going. We have two important concepts. We have instantaneous speed, which is kind of like a snapshot of like how fast you're going right now. So here's the speedometer on my Volkswagen at 62 miles an hour at that particular time on the freeway. So the instantaneous speed, just a snapshot. The average speed is over a longer period of time. So let's say you wanted to go from Minneapolis to the Black Hills. So you can see the distances if you're flying or if you're driving. I don't know if I'd like to drive to the Black Hills. This is kind of cool. So, you can see that the longest distance is 655 miles, and they estimate, about 10 hours and 11 minutes. So if we do the average speed of that, and we're going to look at the 655, the longest distance. So that's the distance. It takes about 10 hours, and that's an average of about 64.3 miles per hour. So because you're not always driving the speed limit, right? You have to stop. You have to go to Wall Drug. You have to get some free ice water. You have to stop and look at the dinosaurs. Your little brother has to go to the bathroom. You have to stop for lunch, whatever. So that's kind of an average speed, the average speed. So instantaneous versus average. We can take a look at speed a couple of different ways. You've probably rarely seen a distance versus time graph, but here's a way of looking at speed. And I want you to look at graphs A and B and look at the line, the blue line. I think it's blue anyway. Why are they different? What's the difference between A and B? So in your notes, just pause for a second and write down what's the difference between those two, because there's an important difference between graphs A and B that I want you to consider. So jot some notes down about that. If you have to sketch it, go ahead and do that. All right, so what's the difference between A and B? Hopefully you paused and did that. The slope is different. So what does the slope indicate? Well, the slope indicates the rate of how fast something's going. So the distance divided by the time. So you can see that the distance traveled in A is greater over the period of time than it is in B. As a matter of fact, it's like twice as fast. So the rate is twice as much. The slope is twice as much as well. Over in C, it's a little bit different. We have some increasing increasing slopes, a positive slope. So between 0 and 8 seconds. And then between 12 and 20 seconds. But then what happens between 8 and 12 seconds? Why is that line flat? What's the velocity? What's the speed of that object, whatever it happens to be? Can you answer that? Tell me, what do you think? Why is it flat? So on a graph like that, if its distance isn't increasing over a period of time, what's happened? Well, it's at rest. It's not moving. So that flat line, as opposed to the line with a positive slope, indicates that it is going it's going nowhere. What if the line was going down? I guess I didn't include an example of that. What if the line was going down? Well, then we'd have a negative slope, which means the object would be slowing down. And we'll take a look at some of those as well. So speed in distance versus time graphs. All right, now what about velocity? Sometimes you only know the speed of an object, and sometimes you want to know its direction. And that's, if you are talking about velocity, then velocity has those two characteristics of vectors. It has direction and magnitude. So that kind of makes a difference. If we're traveling east at 12 miles an hour, that's a velocity. If we're just saying we're traveling at 12 miles an hour, that's a speed. So here's a guy on a skateboard. He went about 4 centimeters per second to the right. That's a velocity. So the magnitude, in this case, in this vector, is the speed. Ooh, paper airplane traveling 12 centimeters per second to the left. That's a velocity because it has magnitude, the speed, and direction. Okay, it's kind of a goofy thing, but when we talk about velocity versus speed, that's an important characteristic. All right, how about some maths? So a woman jogs 10 kilometers in an hour, stops for an hour, and then walks another 10 kilometers for 2 hours. What's her average speed? What's the average speed? You can hear my dog. My dog just came in. You can jingly. So pause this and do the math. See if you can figure that out. All right, so the answer is C. So there's the formula. Speed equals distance divided by time. And there's the maths. You can look at that. So she winds up traveling an average of 5 kilometers per hour, even though for that second hour she didn't do anything. She didn't go anywhere. All right, so here's another one. What about this? Lisa plots on a time on an x-axis of a graph, distance on the y. So what's the slope? Tell her. It tells her the speed. It doesn't tell her the velocity. So if you thought velocity, that's not correct. It doesn't have a direction. It has a magnitude, but it doesn't have a direction. And one more here, quick. So this Lisa's just crazy about these graphs. She plotted some time in seconds on the x-axis and the distance in centimeters on the y. You can see what the plots are. So why don't you see if you can figure that out. If you want to draw a time and distance graph, just sketch that into your notes. So what's the speed that she's calculated then? So the answer is B. So I used the slope formula. So I got the difference over the rise divided by the difference over the run, and then subtracted, did a little division. You get 2 centimeters per second. So that's a speed. It's not a velocity. Okay? So speed and velocity, two important factors when we talk about objects in motion. Hope that helps.